Hello everyone. Today we are going to learn about caching in Nestjs. Let's start by creating a new Nestjs project using the Nestjs CLI. Once the Nestjs project is set up, I run it in development mode using yarn start dev. By default, the app will run on port 3000. For testing purpose, we will implement a testing route that fetches data from a page server. We will use Axios to fetch data from a public API within our service in app module. Once the data is returned, we can test it on Postman, which should provide an array of objects. Now, let's focus on setting up caching in Nestjs. We have two caching options: in-memory caching and use caching store like Redis or MongoDB. For in-memory caching, which is store as data in Nestjs runtime variables and will be lost if application restarts. And the other side, using a cache store like Redis, MongoDB, or any other preferred storage, data will be never lost if application is restarted or cached. For this purpose of understanding, let's begin first with in-memory caching. To set up caching in Nestjs, we will need to install few dependencies: Nestjs Cache Manager and Cache Manager package. To enable caching, import cache module in the app module and call its register method, which has a few options that we'll cover in later video. To interact with Cache Manager instance in your app service class, you need to inject it using Cache Manager token. Import Cache class from Cache Manager and also import the Cache Manager token from the Nestjs Cache Manager package. Cache Manager provides 5 methods that we can use to interact with cache storage. The first one is get method, which will use for getting data by using key, and also has set method, delete method using del, and lastly the reset method. Now let's implement caching for testing purpose by adding the public API response into the cache. We will use set method providing a key, for example my test key. Before making the request, we will check if key already exists inside the cache storage. If it exists, we will return the cache data, and if not exist, we will make a request to the public API. As a result, the behavior will be as follows. First, it will check if we have cached data. If it's present, we won't call the API again, and we will directly return the cached data without making an additional call to public API. Now open your Postman and test the route. If you pay close attention, you will notice that the initial request takes a few seconds to complete. However, once the first request is done, the data is stored in a cache, and subsequent request retrieves the data from the cache, resulting in much faster response times in milliseconds. To gain better understanding, let's insert some console logs into our code. By doing this, we can track and see the source of our data. Now again, test it on Postman. If we hit the API, it will first get data from API. Now let's request it again. Now we can able to see the console log will be from cache. The cache by default is 5 seconds. So if we hit this API again and again, after the 5 seconds, it will get data from the API. To increase the default expiration time, we can apply it within different scopes. To begin, let's modify the cache method using the third parameter of the cache manager method, where we can specify the time in milliseconds for caching. For instance, we will set the time to 30 seconds, which correspond to a value 30,000. Now let's testing in changes. Within 30-second time frame, if we make another API request, we will receive the cached value, resulting in faster response. Now we will explore how to implement caching at the controller level, enabling us to cache the entire response for a specific duration. Let's proceed with caching inside the controller. Firstly, we should remove the caching functionalities from the service. Next, open the controller and apply the cache interceptor from the Nestjs. Now let's open the Postman and observe the result. As you can see, the data is now returned faster as PVS from the cache. Additionally, if you notice that during the fast request, it goes to service and call the console log. But within the cache time period, the service is not invoked. Instead, the controller retrieves the complete previous response from the cached data. We can also set expiry time in the controller using cache_tdl and the parameter of milliseconds. If we wish to apply caching to the all routes belonging to this controller, we can conveniently define the decorator at the controller level. By doing so, caching will automatically be applied to all the responses for the every route within this controller, and the result will be as same as previous. Furthermore, if we desire to apply caching throughout the entire application, we can achieve this by defining it at global level for all routes. This can be accomplished by using the app interceptor in the provider section of the app module. To proceed, let's remove the caching functionalities from the controller level and define the caching at the app module level. We can use the cache module register function configuration to set the caching time or time to live duration, which will be applied to the caching across the entire application. Upon testing the application again, the result will be similar to what we observed previously. This is the overall flow of implementing caching in Nestjs. Now, let's move on to using redis as our caching store. To begin, we need to install redis and ensure its server is up and running. You can refer to official redis documentation and follow the appropriate guide based on your operating system for installation. Next, in order to use redis as the data store for caching in Nestjs, we must install package called cache manager redis 8. Once it's installed, we will configure it within the cache module register method in app module. This method accepts a store, which will be the redis store from cache manager redis 8. The host will be localhost and the port will be the reader default redis port, which is 6379. Additionally, let's change the expiration time to 1 minute corresponding 6000 milliseconds. With these changes, our application is now using Redis as its caching storage. To test this, let's open Postman and make request. As you can see, the results are the same as before. Now let's start our application, test it again. We will notice that our cache is still valid. If we inspect the redis store from the command line, we will able to see the values of the key stored inside redis store. Thank you for watching. See you in next video.